Introduction to Vectors. When we talk about measurements, we're going to classify them as two different types of measurements. Our first type of measurement is called a qualitative measurement. And those are measurements that don't have any kind of number or unit to go along with them. Like saying something is hot or something is cold would be considered a qualitative measurement, or saying something is fast or slow. Not really going to help us very much. The other type of measurement is called a quantitative measurement. And when we talk about quantitative measurements, these are ones that utilize numbers. They have units to go along with their numbers. They're more reproducible when we talk about quantitative measurements. And there are two types of quantitative measurements. The first are what are called scalar, and the second are called vector measurements. When we deal with scalar measurements, they're measurements that only have a magnitude. They only have a number and a unit to go along with them. They need units to identify what we're talking about. They can be worked using ordinary math. So saying something has a temperature of 25 degrees Celsius is an example of a scalar measurement. Vector measurements have a little more information. Vector measurements have a magnitude and a direction. They're represented with arrows. The length of the arrow represents the magnitude of the measurement. So if we're looking at a measurement that's small, the length of the arrow will be small. And if we're talking about a measurement that's large, the length of the arrow would be large. The direction is represented by the way the arrow is facing. And when we talk about these arrows, they'll be labeled with the number for the magnitude and the unit for the identification. When we talk about vectors, we're going to have to do some different things with the mathematics. So here's an example of what a vector would look like. Okay, in this case, our vector is pointing towards the right. Okay, we've got our tail at the beginning of the arrow, and we've got the head at the front of the arrow. And the head of the arrow is always pointing in the direction in which the vector is going. So let's talk about vector mathematics. When we deal with vectors, we know that we have a magnitude and we have a direction. The length of the line is going to indicate the magnitude of the value, and the arrow head is going to represent the direction of that vector. Displacement vectors show the change in position. So we started here and we end here. That's considered our displacement vector. Velocity vectors represent motions. And often we use velocity vectors and displacement vectors when we talk about navigation. When we combine vectors, we have to use some rules. First rule is that when we combine vectors together, we always draw the vectors, the head of one vector to the tail of the next vector. Vectors can be moved with two conditions. The first is we can't change the magnitude or the size of the arrow. And the second is we can't change its direction. Now we need to talk about what resultant vectors are, and then we'll look at a couple of examples. So when we talk about resultant vectors, they are the sum of our vector addition. They're drawn from the tail of the first vector to the head of the last vector. And it shows the net effect of the combination of all of the vectors. So if we were to look at this example here, we have a plane that's flying with a velocity of 100 kilometers per hour, and let's say it's going south. And we have a wind velocity that's 25 kilometers per hour, and it's going west. That wind is going to push the plane in the westerly direction. The resultant distance is going to be what we call our resultant vector. So let's look at a couple of different examples. Let's say that we have an airplane and it's flying east at 100 kilometers per hour. And it's going to be affected by a wind that's going in the same direction. Sometimes it's referred to as a tailwind. So let's say the tailwind is 20 kilometers per hour. We would have to put those two vectors together to come up with our resultant vector. So let's say that we've got our plane traveling in the eastward direction at 100 kilometers per hour, and it has a tailwind of 20 kilometers per hour. Well, a tailwind is going to be going in the same direction. So we've got an additional 20 kilometers per hour. We want to find out what our resultant vector is. And in this case, because both vectors are going in the same direction, our resultant vector is going to be the sum of the two. So our resultant vector would be 100 kilometers per hour going east plus 20 kilometers per hour going east. So our resultant vector would be 120 kilometers per hour due east. Now let's look at what's called a headwind, or a wind that's going against the plane. And let's say again that our plane is going 100 kilometers per hour, and we're going to have a headwind that's going 20 kilometers per hour. Now the wind is going against the plane. So if we wanted to find out what our resultant vector would be, it's actually going to be less than what our original vector was. And to calculate that, we would subtract. So we have 100 kilometers per hour in the easterly direction. We've got a headwind, or a wind that's going against the plane, at 20 kilometers per hour west. Our resultant vector would be 100 minus 20, or 80 kilometers per hour going in the easterly direction. So let's look at one last example. Let's say we have a plane that's flying north at 80 kilometers per hour, but there's a wind coming from the west at 60 kilometers per hour, and we want to find out what the resultant vector would be. All right, so we'll start with our plane. We said that our plane is going to be going north and it's going at a velocity of 80 kilometers per hour. And let's say our wind is going 60 kilometers per hour east. Well, to add that second vector in, we're always going to put our vectors tail of the second vector to the head of the first vector. So we'll go in this direction, and we've got 60 kilometers per hour. We want to find out what the resultant vector is, or we want to find out what direction and what the speed of that plane would be. Well, we're going to connect the tail of the first vector to the head of the second vector. And since the plane is going north and the wind is coming from the west and going towards the east, it actually forms a right triangle. If we want to find our resultant vector, we should look and see that this is really just a right triangle, and we're going to apply our Pythagorean theorem. So we've got a squared plus b squared equals c squared. A will be our 80 kilometers per hour, so we'll take 80 kilometers per hour, and we're going to square that number. We'll take our wind speed, which is 60 kilometers per hour, and we'll square that. And that's going to give us the resultant vector squared. So 80 squared is going to give us 6,400. 60 squared is going to give us 3,600. And that's going to equal our r squared. 6,400 and 3,600 is going to give us 10,000, and that equals r squared. We take the square root of both sides, and r will equal 100 kilometers per hour. So our plane will be traveling 100 kilometers per hour in the northeasterly direction.